Alright, hello and good morning everyone. My name is Jared Hansen, mechanical design engineer that specializes in product design, but more importantly this video, I recently did a project where I had to incorporate Neopixels into a project that was using a Raspberry Pi, which is, I use Neopixel all the time with Arduino projects, but it was extremely confusing getting into doing this with Raspberry Pi, needing special hardware such as the logic level converter, etc., and just getting all the basics set through, because all the videos I was finding skip steps, or they didn't show it, or they didn't mention this one library you needed. So I'm going to go through and show you every single thing you need to do to set this up, with links to all the tutorials on more details on each one. I'm going to try not to go too far into the weeds on some things, like the basics of Raspberry Pi or VNC Viewer, but I'm going to provide great links that I found that I use when I set up a new Raspberry Pi. That will show you step by step how to do so. But more importantly, I'm also going to show 4 different ways you can wire this. I tried to make this video last night and it was over 20 minutes, so I'm probably only going to show you the easiest way and then what I consider the best way. With this middle one, I'll still leave the tutorial on how to do it, and if we have time to do it. But there's 2 ways you can do this middle one. But basically you have the easiest way, which is just the Raspberry Pi and some Neopixels and some wire, and then the best way where you can run more Neopixels off of Raspberry Pi, but you need a separate power supply so you can run more of them, and a logic level shifter or converter. Okay, so that said, I know a lot of people are super bored by the coding part of it, so we'll start probably with the setting up the wire for one of the circuits and then do the next one. So I'm also going to reset my Raspberry that I'm using back to day 1 settings, factory reset, and I'm just going to install the OS here. So you can see I've already set it up, have the new flash drive I'm going to put in it, and so you know for sure if you set yours to this OS that we're using the same setup. Okay. Let's see, did I miss anything? Wiring, 4 methods, nope, and let's see, yep. Okay, so let's jump right in. So wiring, here's the 4 methods I planned on showing. Like I said, I'm gonna do these 2 first, the easiest, and then what I consider the best, and then I'll go into these if we have time. So you can follow this link here to the Adafruit webpage, where they go in higher detail on these circuits. You can see it's the exact same circuit I pulled right from them. It's a great article. It just, they were missing some little details that I was needing. And we're gonna also use code from that in a minute. But okay, so circuit 1, the simplest, can only be used with a low number of LEDs. I don't remember what it was, but for this test I just put 3 on there. I think it's like 10 or something. But that tutorial will shed more light on that. And all you need is Pi and LEDs and wires. So let's discuss that. So I'll go ahead and aim the camera down at the Pi. If you see here, let me go in full screen. We have the 1 power wire going to the LED strip, 1 ground, and 1 signal wire. Okay, signal wire is plugged into GPIO 18 or pin 18, and I'll go ahead and show how you can reference those. So here's a great little image, and I'll attach these sheets here, or slides, as a PDF when we're done. So we were using GPIO 18, which is here. Oops, button drag that. So we're using that here. For ground, we are using the ground right above it, so pin 14. And for power, you can use either 2 or 4. I'm using 4 in this just to make sure that I follow this tutorial as much as possible, so that you'll know that we're using the exact same thing. So we're using this one here, and there you go. Alright, so we've wired the circuit. Now let's set it up. Or set up our Pi. So, order of operations, set up the Pi using this great tutorial. So if you haven't set up your Pi, you don't need to set back to the OS I'm using, but if you want to know for sure if you're running into troubles, this could be a great way to know that first step by step you've done it right. So use that link to go through this, set up your Pi, and then set up your VNC viewer using this tutorial. Hopefully one day they'll make some videos on this. It's pretty straightforward though, but once your Raspberry Pi is running, continue to the next page. I'm going to go ahead and pause and set mine back to factory settings so we can test this together. So 1 second. Alright, so we have all this done. You can see this fresh Raspberry Pi desktop, nothing on it. So all I did again was follow these tutorials that I've linked here, where I set up the Raspberry Pi itself, and then went in and set up VNC viewer using these commands in the command prompt, and then configuring it. And then I rebooted the Raspberry Pi, which of course you got to do. Again, I didn't want to show that because I don't want to go too far into the weeds, but and there's some great tutorials on it already. So once your Raspberry Pi is running, continue to the next page. So here's the part that tripped me up, and we're just going to go through it together. So I'm going to open up this Raspberry here and see if we can find a good place on the desktop for that. Okay, so verify you're using Python 3. Okay, how we do that is open the command terminal here, and we're going to type Python -- version Python 2.7.16. So then type Python 3 3.7.3. Okay, so we should be good to go. Because you can see that we do have Python 3. So set up your Neopixels specific stuff. So while we're still in the terminal, we're going to type these 2 lines of code and press enter after them. I guess I'll put that also. Just so it's clear. That. Let's power through. Okay. So let's pull up our Raspberry again on VNC. So I'm going to type pip3 install RPI underscore WS2A1 X ADA T dash Alright, sit there and wait. Hopefully that runs good. Looks like it's going. So I'll let this run so that y'all can see it real time. Okay, now we're ready for the next one. So sudo Python 3 space -m space pip space install space -- force reinstall space ADA fruit blinka. Press enter. Alright, while that's running, I'm going to jump to the next page. I'll pull that back up though so you can see it. So on the next page, we are going to download the code, transfer that file so you don't have to write your own code. I'll show you how to change it to the number of Neopixels you're using, and then we'll run our Neopixels. So that ran great. I'm going to go ahead and exit out of the terminal and then jump back to my computer. I'm going to follow the link here, link to code. Click that. Zip down to here on the page below these pictures, full example code. Download project bundle. You could also copy the code, I guess, and then put it yourself, but this is the easiest way. Just do it this way. Okay, examples. I'm going to open that zipped file that I just downloaded. Open examples. I tested both of these and they worked, so I'm just going to grab one again. Let's do CircuitPython 7. So inside of that, grab code.py and drag and drop it to your desktop. Okay, so once that's there, let's open our desktop and find it. Here, one second. Open up VNC Viewer. That's what's in our steps. Download, transfer code file to VNC Viewer. Okay. So we're going to go VNC Viewer. Holding my cursor at the top, you'll see transfer files. I'm going to click that. I'm going to select send files. Desktop. We'll look for it. Code.py. So before I send that, I'll leave it named code.py in case I'll leave it named that. Open, exit, VNC Viewer, transfer file, transfer, exit that. Okay, now you see it on our desktop here, so we're good to go there. I'm not sure if I listed the things here, but it's not super important, but let's go ahead and double click this. Wait a second, and we can go into line 15 here, where it says 30. As you saw on my circuit, I have 3 Neopixels, so I'm going to take away that and run it on 3. And then I'm just going to do Control S, save. I'm going to exit that. Now let's jump back to the steps. Again, I don't think you always have to do that. You don't have to with Arduino, but because if it says 30 but there's only 3, it'll still run 3. Alright, transfer the code file. Place the chosen code on your desktop home screen using these steps. So open the zip file, open either of the folders, drag them, place the chosen code. I showed you a different way of doing that. It's easier. So I'm going to get rid of that. So desktop screen. So we've done that. Using, that's good. Alright, open the terminal and type. So we're ready to run. I'm going to open the terminal again. We're going to type cd space desktop with a capital D. Alright, now you can see our directory is now desktop. So now we're going to type sudo space python 3. That was throwing me off not typing python 3. I was just typing python, but we verify we're using python 3. So code.py. I'm going to press enter. Alright, and now that that's done, our Neopixels should be running. So let me set my circuit back down, pause that, and I'll aim the camera down. Alright, as you can see, my Neopixels are running, and I'll show that one more time so you see it real time. I'm going to type in to the terminal here. I'll type our hold control and type C, and that will end the light show. And then I'll run them again by typing sudo python 3 code.py. Enter. Okay, 1 Mississippi, 2 Mississippi, 3, and they're running. So again, to end that, hold control, type C. Okay, so that'll be the same code we type for each method. Now, how long are we at? Are we over 10 minutes? Okay, I think it's probably still worth showing you how to do the logic level controller, because that's the better method of doing this, but I'm going to really rush through it. But luckily we don't have to do the coding and setup again. So let me pause and set up the wiring for that, and then I'll show you it. Alright, sorry about that everyone, but as you see here, I wired up the circuit real quick, remove the other ones because we don't have time to go into the 2 middle ones, which honestly, if you're going for more than 10 LEDs, maybe just buy that logic level shifter. So the same pins are used, except now the 5 volts from the Raspberry goes to LV, pin LV, which is low voltage. The signal goes to LV1, so low voltage signal 1, because it's a 4-channel converter. You can do 4 different strips with this. And then ground, this is the important part. Ground, it's grounded to the 5-volt supply. So I use an Arduino Uno here for my 5-volt supply, just because it's already on the test stand. And you connect their grounds together. The high level of the Arduino, or the 5-volt coming out of the Arduino, I put it on this rail here, so it's running all the way down. Same with this ground, running all the way down. And then the ground goes to ground, LV1, or high volts, HV. This red wire goes to the Arduino, high volts. And then the HV1 channel goes to the strips. And the strips, are power and ground are coming from the Arduino. So, pretty straightforward. And let's jump in and watch that live. So, I'm going to pull up Raspberry again, same thing. So we're already doing the desktop. Let's go ahead and start fresh. Just so, in case you log out, C, change directory, CD, uppercase, desktop, and sudo python 3. The code's name is code.py. Enter. And you should see on here, yep, see that it's lit up. And you can see them going through the code, changing about. So we are good to go. Let's jump back out. I'll show you some other information real quick. So first, the logic level shifter I used there, it can be bought here in these links. You can use all kinds. Adafruit makes some great ones, but I just wanted several so I could make mistakes and have them in my bin, since I do most of my work is prototyping, so prototyping for inventors and just different companies. So I just wanted these, and you can control several different strips. So I think 4 on this one. Yeah, 4 channels. So if you just want to use the exact same thing, these are the ones I bought, and I made sure to get everything out of Amazon. You can also find the LED strips I use here. You see these when they pop up. They're pretty affordable. Most stuff I buy, I try to buy module versions of everything and cheap versions of everything, because I'm shipping base level prototype. You can find the Raspberry Pi 3B there. This also works on a Raspberry Pi 4, and it should work fine on a 0. So there's the wire I use, SD card I use even. There's a Raspberry Pi imager, which is actually in the tutorial thing, and there's again the Neopixel article. Picture of GPIO output. I didn't link that because it's right here in these slides. And let's jump back, see if there's anything else. That looks out of order now. Isn't that up there? Oh well. Oh yeah, it was. Okay, I put that picture in the wrong spot. Okay. Move that one more time. Oops. Okay, yeah. So we did that. There's the wiring, links, and I'm not going to go through these and add a picture of each. Because that's the only kind of special one. I just include the picture because I'm using a different converter than they are. So, pretty straightforward. Hope this was helpful. Feel free to suggest anything else you'd like to see. Actually, the video I was planning to post, I had a goal for by lunch today to post a video. I was actually going to post how to 3D scan existing objects with using your iPhone on all free software, and then make a 3D printed replica of it, or so you can do editing, because that's also great for reverse engineering, prototyping, etc., and incorporating things without having to model it. Like, this is a very organic, weird shape, so this would be something that's great for scanning, and a free method is always appreciated, of course. So that's coming up next, and we're almost at 20 minutes, so I'm going to go ahead and end here. If you have any questions, whatnot, you can also jump on my Discord server, which I'll link. It's just me and a couple of people that just talk about Fusion 360 mostly. But any product questions and whatnot you have, or suggestions, it's a great resource for that. Okay, I'm going to sign off. Thanks.